Hi, hello everyone. Are you guys able to hear me? Is my
Yes,
voice
sir.
audible? You're able to hear me?
Yes, sir.
Okay. So, okay. Yeah. Thank you. So, today we are going to discuss some of the important concepts that uh, will be very like those concepts we have already discussed many times before that. But just as a revision, I'll just be going through that. Not the topic, but I'll just solve some problem that can help you to revise those concepts. Okay. So, this is how we'll do. We'll solve some 10-15 problems. And if you're able to solve those, you are good at your preparation. Your preparation is going in the right direction. See, for the signals, starting 4 weeks, you doesn't have much of the content. Mostly, some of the standard signals you should be knowing. Okay, I hope that has already been discussed in some of the previous sessions. Okay, like the unit step, delta function. The properties of the delta function is the important. You'll be getting some 2-3 questions for sure. We'll be having altogether 15-16 questions. Okay, of 1 hour that you already are aware of. Some of them will be MSQ, some MCQ, and then NAT. So 50% of the paper mostly will be from MSQ and MCQ, and 50% of them will be NAT. Okay, for quiz one. Some questions will be so you'll be getting. I told you already. So some of the standard signal you must be knowing. Some of the basic features about those. For unit step, you already aware of that. What is that unit step and all? Ramp function you should be knowing. The most important is the delta function because from delta you will be getting 3-4 questions. Okay, the implication at least 2-3 questions will be there for sure. Whatever question that I've seen that is coming, so you'll be having 2-3 questions for sure. So the properties of the delta function should be clear. Okay, and whatever we have discussed, I guess in one of the session I've discussed some 5-6 properties of the delta function, and that is important. Okay, if you have just practiced the graded and practice also, each and every question has been prepared by me. So if you have just practiced those questions itself, you'll be good at that. Okay, many of them are gate questions also. So if somebody is just practicing the gate questions, you are good at that. Okay, so all the gate questions has already been covered in some or other way. Okay, so ESE and gate question mostly. Okay, in your assignments also, and then in the quizzes and all also, you'll be getting similar type of problems. Okay, not exactly same, but yeah, inspired from those questions itself. Okay, so this is done, and yeah, ramp function is also important, and then the very basics about the triangular function and the rect function. Okay, rectangular function. Okay, rectangular function can be asked directly. Let's for example, you can be asked a rectangular function can be given, and then you can be asked to calculate the energy, like a combination of a rectangular and a triangular. Like for example, a trapezium. You can calculate directly also, like with the formula that you have for the energy. But if you know for some of the standard signal like rectangular and the triangular sinusoidal curve, nor if you have the energy from like the formula already, then you can directly calculate it for the trapezium signal also. Okay, can somebody tell me what is the energy for a rectangular signal or for a triangular signal? What's the formula? Like formula, I mean to say we have derived that. So how do you calculate that energy? So let for example you have a rectangular t upon tau. Okay, a times rect function. Okay, I'll just write it here. A times what is the energy for this function? Okay, so this is some a square tau, right? So this is the energy that you calculate. Okay, but if you have not gone through that, you can just revise that. You can just go through my last session that I took. I guess that was 11th of October. I guess this is the slide that I have dealt there. Okay, and this is yeah. So I have written also many of the mostly I have derived all the for all the standard signal. I have derived the energy, right? You can see that for a rectangular signal, it might be somewhere, but yeah. No, it was derived. I don't remember where it was, but yeah, it was covered. So you can just go through the slide itself. You'll be able to uh, get each and everything. Okay, all that I can for you can see it for a exponentially decaying function also. It was. calculate it. So if it is a just a one phased, it will be the energy will be 1 upon 2a. Okay, and if it is a both phased, okay, like a mod has been applied, then the energy will be 1 upon a. Okay, and you already are aware of what do you mean by energy signal. If the energy signal has been set, then the power will be zero, and if a power signal you are dealing with, then uh, the energy will be infinite. Okay, and the power will be finite. Okay, for a sinusoidal signal, also you already are aware of your power will be what square by 2. Okay, so these all things was dealt in the last session. You can see that, right? For this is a rectangular function. Okay, the energy was a square t, right? T was the full width. Okay, and similarly for a triangular signal, you will be having a square t by 3, and if you are writing the full width, then it will be 2 times a square tau by 3. Okay, this is how generally you calculate. And if you have a signal like this, right, for this also we have calculated, and the energy was a square b by 2. I hope you might be aware of those things and you would have remembered all. So here you can see all the things. Three important signals has been written here with the energy. So what can be asked is uh, a trapezium. So this is a rect function, right? For this rect function, you can directly calculate the energy, and then you can calculate the energy for this triangular and this triangular. So you'll be having E1 plus E2 plus E3, and you can see that these three are non-overlapping. So you can directly write the energy of this A, B, C as energy of E1 plus E2 plus E3. Okay, because all the three are non-overlapping. If it was overlapping, then you can't write it, but all the things was discussed, I hope. So okay, let's go and then solve some problems. And if you're able to solve this, whatever 10 or 15 question we are solving it, most of the problem, at least from the last 2 weeks, you'll be able to solve in the quiz paper also. Okay, so how will you solve this? So you have a power signal. You can see that this is a periodic signal. Okay, and for a periodic signal, can somebody tell me what will be the energy for this signal? What will be the energy for this periodic signal? So just now I discussed, right? Are you able to hear me, or am I just talking to myself?
Periodic signal energy is infinite.
Correct. Yeah. So the energy is infinite. What will be the power? How will you calculate the power for the signal?
Power is an average of a energy. Actually.
Correct. So the average of a
Energy.
generally power when you calculate, that is nothing but the average of like whatever energy that you'll calculate, the average of that. But so you can just calculate the energy for one time period. Okay, and then upon the time period. Correct. This is how generally you calculate the power if you are dealing with a periodic signal, right? So what do you think? So this you can just, what is the time period here? Is it one or two?
Two, sir.
Two. Correct. So now if you have to calculate the power, if you have to calculate the energy for one time like from 0 to 1, because there is nothing from 1 to 2, so you have what? You have just 1 square and upon 2, so you'll be left with 0.5 watt. Correct. Is it clear to everybody?
Yes, sir.
Okay. Now the next problem is you have been given a trapezium. Okay, you can see that there's a combination of a rectangular pulse and two triangular pulse. Okay. Now the first question is to plot this x times 10t minus 5. Okay, I hope you will be able to plot it. Okay, there's nothing like, you can just come like from the right hand side, and then first you can just shift it, and then you can scale it with the 10. If you are scaling with 10, you just, so let's for example the first one is shifting, right? You can just add 5 everywhere at each point. Okay, and then you just divide it with 10. Okay, you'll be able to plot x of 10t minus 5. I hope that you will be able to do. Now, first you have to calculate the energy of this signal, then only you will be able to calculate the energy of x of 10t minus 5. Okay, what will be the energy of this signal? Can somebody calculate energy of this one, E1, then E2, and then E3? What will be the value of E1? E1 is very simple. This is a rect function, right? With a full width of 8. correct? So you already know that formula, a square times full width upon, yeah, a square times full width, right? A is 1, so 1 square times 8, correct? So 8 joule. From here E1 is equal to 8 joule. Now you have to calculate for E2 and E3. How will you calculate for E1 and E3? I already told you formula, right? 2 upon 3 a square t, correct? So if you'll calculate it for, let's for example, this for E2, you'll be left with 2 upon 3 times 1 times 1. So 2 upon 3, right? Sorry, what will you get? 2 upon 3 a square is 1, right? And then t is half, because here you are taking half width, right? So you'll be left with 1 upon 3. So 1 upon 3 from here and 1 upon 3 from here. Okay, so 1 upon 3 joule and here 1 upon 3 joule. So the total energy will be E1 plus E2 plus E3, and that is 8 plus 2 upon 3 joule. Anybody has any doubt in this? So you have calculated for xt. Now you have to calculate it for x of 10t minus 5. What happens if you are doing the scaling? What will happen on the energy?
Scaling will decrease the energy by mod A, that 10, factor of 10.
Yeah, it will decrease, right?
Yes, sir.
By 10 times. Correct?
Yes, sir.
Yeah, correct. See, whenever there is a scaling factor has been applied, okay, that 10 will get divided. So here the energy, let's for example, the energy was E, here it will become E upon 10. Okay, now what will happen here? What will be the energy of x of 5t? E upon 5. What will happen here? E times 5.
Multiply by
Correct. Now this is important. So now you have to differentiate this plot and then calculate the energy. Okay, so you have a trapezium, you have to differentiate it and then calculate the energy. How will you do that? What will you get if you will differentiate this trapezium?
if we differentiate triangular function, we get the
You'll get a rectangular, correct?
rectangular, and for the constant we get a zero.
Yeah, so from here to here you will get 0 for sure. So let's for example there is a function, so and then this is minus 4 and this is 4, so from minus 4 to 4 you'll be getting 0, right? But from minus 5 to 5 you'll be getting a constant value and that will be positive, right? Okay, because you can see that the slope is positive, so if you'll differentiate you'll get, this is something, what, this is a ramp function, right? If you'll differentiate a ramp function you'll get a unit step function. Okay, even though if any somebody is not able to understand, you can just write it. Okay, how will you write? So this function starts from minus infinite and comes to minus infinite to minus 5, it is 0, and minus 5 it is getting a ramp function, so ramp of t plus 5, then it is the slope was like this, then the slope must decrease at minus 4, so it will be ramp of t plus 4. Okay, and then again it should start declining at 4, so it should be minus of ramp of t minus 4, but at t at sorry, at this point it should decline, but if we will not write anything it will go like this, but we'll have to increase the slope, so it should be ramp of t minus 5, right? This is the function, this is xt. Now you have to differentiate it, d of xt by dt. So if we'll differentiate, the ramp function will change to a unit step function, minus u of t plus 4 minus u of t minus 4, and then you have plus u of t plus 4. If you will write it, you will get something like that. So it starts from minus 5 and should decrease to minus 2 minus 4. So the function something should go like this. Okay, and then from minus 4 till 4 it will be 0, that is fine. And then at mine and 4 it should decline, there should be a slope or ladder should go down. Okay, so it should be something like that. And then at plus, sorry, here should be 5, at it should be minus 5, t minus 5, at 5 it should increase, so it will go like this, correct? So this will be 1 and this will be minus 1. So this is the differentiation d of xt by dt. Now you have to calculate the energy. You can see that both the rectangular pulse are totally non-overlapping. So you can directly calculate energy E1 here and E2 here, and you can just add it. What will you get for this energy signal? This will be 1 square times 1, correct? And here it will be minus 1 square times 1. So you'll be having 1 plus 1 equals to 2. Anybody has any doubt in this? You can just let me know. No, right? Okay. So, and you already have calculated the energy for xt. So, this type of a problem can come as a comprehension, and this is very highly prone to be asked in the quiz also. So, you can just practice it out. So, a given signal, because they're able to test it everything, right? Whatever has been taught in week 1 to 4, they can ask you scaling, shifting, everything, and then energy also can be asked here. Is it fine to everybody? I don't think so. These are difficult. Okay, landscape mode. If I'll do in a landscape mode now, what will happen is you'll not be able to see it. Okay, I can do that. Okay, if it is fine, then I can just square with this. Okay, and this I already told you. The energy for this is a square tau, and here it was 2 by 3 a square tau. Okay, see, so this formula, if you are able to know, you'll be able to solve some problem for sure. So this, can you just solve this one? Just minutely observe this, you'll be able to solve it for sure. Just see whether this is a function or this type of a, which type of a signal has been represented with. So this, just by looking at this, what do you think? What do you think? This is a rect function, this is a triangular function, right? So this again is a trapezium, correct? So this is a trapezium, so from minus 3 till minus 2 it is going like this, and then from minus 2 to 2 the value is constant and then it is declining. So this is a trapezium signal, and then we already calculated the energy. So I hope you'll be able to calculate the energy for this signal also. Any doubt? Anybody has any confusion in this? I don't think so, right? Okay, you just keep on telling me also, so that I'll be able to understand that you don't have. And if you're, I'm telling you, if you just solve these all questions, whatever I am solving, you'll be in a good position to solve each and every questions of the quiz also. So if you're not solving now, at least try it at home also. Like, you're at home only, but yeah, try it at later time also. And after this, you'll not be having any session till quiz paper. And after quiz paper only, you'll be having any session. And we'll start with systems. Okay.
Sir, sir,
Yeah.
have you shared the 11th October class notes
I don't
in
think
that group?
so. I have
O-
said it in GS space, but okay, if you want, I can just share it again after this
Okay,
session.
if okay. Please share it here.
Okay, I'll share on the GS space again. You are there, right, in the GS space?
Yes, sir.
Okay, I'll share it again. Yeah. So both the slides I'll share.
Okay, thank you, sir.
Thanks. Okay, how will you calculate the energy of this signal where you are differentiating the rect function? If you have a rectangular function that is from minus half to half, if you will differentiate this, what will you get?
We get zeros was constant.
No, but okay, so from here 0 to 1 you are getting, right? So there's a sharp change, right? So what should you get? Impulse,
That's impulse.
right?
That's
Because
Voice
differentiation, what
delta.
rate of change, right? correct? Differentiation is nothing but the rate of change, right? So we are changing from 0 to 1 directly, right? So there must be a ramp, not ramp, impulse at 0.5, and here also at, again you are going from 1 to 0, right? So there will be, must be a ramp, sorry, a impulse at 0.5 also, sorry, minus 0.5 and 0.5. So will you be able to calculate the energy here? So this is infinite, this is also infinite. Will you be able to calculate the energy here? So what will be the energy here?
One.
Energy can't be one here, right? This is not a some fixed finite. So energy signal you already know, right? There can be only two conditions for an energy signal, right? Either it should be a bounded signal. If it is not bounded, then it should, the magnitude should tends toward zero, as the t tends toward infinite or minus infinite. Okay, there can be only two types of signal, those can be in energy. So the first condition can be energy signal. There can be two conditions, nothing like more than that and nothing less. So the first one is the finite magnitude fixed boundary. Okay, any shape can be anything, doesn't matter. The second is, if you have an infinite duration, right, then the magnitude of the function signal should tend toward zero at as mod t tends toward infinite or minus infinite. Okay, so let's say example, what is the example of this? The exponentially decaying signal. Even though this is an infinite signal, right, but the t starts tending toward zero as the, so this is like a one type of a signal, or it should go like this, or it can go like this also. So all three are energy signals, okay. And then for a finite magnitude, though, you can have any signals, okay. But the only the thing is the boundary should be fixed, okay. So there can be only two type of signal. I don't think so. This comes under any of the two, right? So this is not an energy signal. This is not even a power signal, but the energy will be infinite. Okay, is it fine, or is it going over that? Fine, right? I don't think so. There is anything that is new has been taught here. Everything has been taught. I can show you also in this session that I have discussed. Okay, I'll just go through it. So yeah, so we started. You can see that in the energy signal, the first type we are looking the finite duration, the finite magnitude, right? Any shape. So this is the first one. This will always be energy signal. The second one was infinite duration, but the magnitude should tend towards zero at mod 10. So this is the three type of signal exponentially decaying, either in the positive side or negative side or on the both sides. So this is like a mod t has been applied here. So this is an energy signal. Okay, and for this we have already discussed 1 upon 2a is the energy, here also 1 upon 2a, and here 1 upon 2a plus 1 upon 2a, so it is 1 upon a, because this is a non-overlapping signal. You can see that, right? The positive side is totally different, and it will start from 0 to infinite, and negative side is starting from minus infinite to 0. So there is no overlapping, so that's why you can add it. If there is overlapping, you can't add the energy signal, you'll have to check something else also. Okay, basically you have to check for the, like, wherever the overlapping things are there, so that will get changed, and then you'll have to plot that signal also wherever this is overlapping. Okay, that also you have to take the into the consideration, then only you'll be able to calculate the energy. Okay, so this is done. I hope any doubt in calculating energy? I don't think so. So any type of a signal can be given to you now, and I hope you'll be in a position to calculate energy. Okay, the most important thing that you should be knowing is for the rect and the triangle, you should be knowing the formula to calculate the energy signal. Okay, fine. Now you have a power signal, and so this signal is from minus infinite to infinite. For power signal also there can be only two conditions. So you can just see it here. For energy signal there are the two conditions. For power signal also there is only two conditions. Either the signal should be periodic. All the periodic signals are power signal. Okay. And the second condition is if the signal is not periodic, then what should? So then if this should be of infinite duration, but the magnitude should be constant, like this signal A of ut. Okay, you can, starting from zero it goes to infinite, but the magnitude you can see is in the constant. Okay, similarly you can have from minus infinite to infinite. Okay, here also you can see we have calculated the power, that was a square, and for in, oh sorry, it is opposite, so this should be, so you can just, this should be a square by 2, this should be or you can calculate it and then check it where you are getting what. Okay, but mostly it should be a square by 2 and there it should be a square. Okay. Hmm? So this is how generally you calculate the power. uh, okay, so there can be only two conditions: either it should be periodic. If it is periodic, then for sure it is a power signal. If it is not periodic, uh, then it should be of infinite duration, but the magnitude should be constant. Okay, let's for example you just have to tell me a ramp signal. Is it a power signal? The magnitude is increasing. Is it a power signal? Can you calculate the power for this signal? For a ramp signal, that is from infinite minus infinite to infinite, the magnitude is increasing, right? So this you can't calculate the power, because I already told you there can be only two conditions. First condition for sure is not satisfying because it's not a periodic. It's a not non-periodic, but the magnitude is also not constant, so you can't calculate. So the ramp function is neither an energy nor a power signal. Okay, I hope that makes sense to you. So you can calculate the power here, right? What will be the power for the first case?
Sir, 100.
Yeah, and what will be about the second case?
Sir, 50.
Hmm. Correct. See. Yeah. Okay. So I already told you if you have an energy signal, a function with an energy signal, energy of E, here it will be E by 2, right? Here it will be E upon some alpha. What will be the energy, area, and power for this type of a signal? For calculating the power, just consider Ft as a power signal. For calculating energy, just consider Ft as an energy signal. What will be the energy, area, and this three things you have to tell me. What will be the value?
Sir, energy k square E by alpha.
Energy k square E by alpha. That seems k square E by alpha is correct. Yeah.
Energy is finite, so power is zero.
No, for power you consider this as a energy, the power signal itself. Like consider Ft as a power signal for calculating power. Let's for example Ft is a power signal. Then what will be the power for this type of a signal? Okay. You got it right. So let's consider this power signal and then calculate the power for minus of minus alpha plus minus t naught. What will be the power here? So see for energy area, so it will be just k times whatever a upon alpha, right? Because here you are doing k square times, right? So here you will just do k times a. So area will be k times a upon alpha. Power will be what? Is there any impact of shifting on power? Is there any impact of shifting?
No, sir. Because
No. Is there any impact of scaling?
scaling also no, sir, I guess. Because we are
Correct.
taking average.
Yeah. So scaling also no. So only there will be impact of k. So it will be k square times p. So that's why there was a question in graded assignment, and many of the students were saying why the answer is 6 watt. Even though I did the mistake here, right? I didn't see the amplifying factor of 3. I hope you can remember if somebody was asking the doubt, right? So the answer was the power was for the signal, whatever the power was 6 watt. Okay, but the signal that I gave was something like x of 3 times t plus some t naught. But here also I gave 3. And this I forgot to while calculating. I guess this graded assignment question number 19. Yeah, correct. So, okay, so this will be 3 square times 9. So this will be 3 square times 6, so 9 times 6. So 54 is the correct. And that has I have already told the team to correct the answer. Okay, right? Okay. Now, which of the following is a non-periodic out of this four? So, I hope this power and energy is clear. If you have to just go through, so you can just go through today's slide and then the last week's slide, and that is more than sufficient to solve each and every problem. And every problem will be solved correctly, okay, with whatever we have discussed in now. I don't think so. Any questions are there that you can't solve it in the exam. All the questions are very simple, and whatever we have discussed, you'll just get those things only. Okay, so yeah. Which of the following is non-periodic?
Sir, third one.
Absolutely right. Yeah, this signal you can see this ut is multiplied, right? So how can this be a periodic signal? Everything else is periodic. Any doubt anybody has in this? Okay, so I'm just skipping one more question. So let's say example you have a signal 1 plus 2t plus 3t square. Can you just tell me the even part of this signal?
Same, sir. 1 plus 2t.
Even part and then odd part also.
Plus 3t square even.
So the even part is 1 plus 3t square and the odd part is 2t. Correct? Am I right?
Sir, 1 plus 3 is 3 square by 2 now. Or
How do you calculate even part? Xt plus x of minus t by 2. Correct? So 1 plus 1 will be 2 upon 2 will be 1. Correct? And 3t square plus
oh, okay,
3t
sir.
square. And then for the odd part, it will get subtracted and we will just be left with 2t. Correct? Yeah. Okay. Can you calculate the fundamental frequency? So all the topics that we are discussing, you can just keep on noticing also. I hope you are here. So these are the only topic that has been discussed. So from each topic
3
you'll
by
be
2,
having
sir.
3 by 2.
No, no, sir. Now I am calculating power.
Okay. And how do you check whether the combination of periodic signals are periodic or not? What is the fundamental way to check that?
Their time period is rational, then
Yeah, the ratio of the time periods will be rational. Okay. Hmm. Let's for example you have T1, T2, T3, right? T4. then T1 upon T2, T1 upon T2, sorry, T3, T1 upon T4. So it should all should be raised to. Okay. Hmm. Okay, let's for example, what will be omega 1 here, what will be omega 2, and what will be omega 3? What is the value of omega 1? Omega 1 is how much? This is 1.2 pi, right? So 12 pi upon 10. So here it is how much? 2 pi upon 1, and here it is 28 pi upon 10. Correct? And how do we calculate? So for omega, if you have to calculate the fundamental omega, right, you take the HCF of all these three. If you have to calculate the time period, you take the LCM. If you have to calculate the HCF, you take the. If you have to calculate the fundamental frequency, right, so you will calculate the omega, right, and then you can divide by 2 pi to get the frequency, right. You already know that omega is equals to what, 2 pi f naught. So if you have to calculate, you can just divide with 2 pi to get the fundamental frequency. So here you have to calculate the HCF of these three. How do we calculate HCF? So HCF of this 12 pi, 2 pi, 28 pi upon LCM 10, 1, 10. Okay, so you'll get something like 2 pi upon 5. Hmm? Right? So if you have to calculate the frequency, F will be omega upon 2 pi. You will be left with how much? 2 pi by 5 times 1 upon 2 pi. So 0.2 hertz. Any doubt here? Okay. Similarly, how will you calculate the odd part of the signal and even part of e to the power jt? Okay, you have to calculate the odd and even part, and then calculate time period. So I hope we are already clear with. Let's for example, you calculate the time period of 200 pi t plus 3 cos 50 pi t. You calculate the time period. Calculate the power. Okay, this signal xt. First, tell me the odd part of this e to the power jt. So if you write e to the power jt, how do you write? Cos t plus j sin t. Which one is the odd part? Which one is the even part? So this is odd, right? This is even. So this is cos t, and then j times sin t is the odd part. Okay. Correct. So I hope this is done. What will be the power and time period for this signal? Just tell me.
Power is 13 by 2, sir. Power is
2 square by 2 plus 3 square by 2. Okay. What will be the time period? Fundamental time period. So what is the time period for this signal? T1 equals to how much? 1 upon 100, right? And T2 is how much? 1 upon 75. So you'll get a rational number, correct? T1 by T2, it will be some 0.75. That is rational. And then you can calculate the time period, right? LCM of 1 upon 100, 1 upon 75. So it will be 1 upon 25 can multiply, right? So 1 upon 25 second. You calculate this. This is also a very simple example. What will be the value? I'm giving the options also 1, 1.5, 2, 3. So xt is already 3 as a time period. What will be the time period here? 3 upon 2. Calculate the LCM. We'll get 3 1. Correct? Are you guys here? Are you able to hear me? Are you guys solving the problems or are you just listening?
Can you discuss this one?
Okay. So here you have so the time period here will be 3 only, right? For x of minus t, correct? Because the time period for this xt is 3 seconds, right? For a signal y of 2t plus 1, right? So yt also has a time period of 3, right? But you are scaling by 2, so the time period will get divided by 2, correct? So here for y of 2t plus 1 it will be 3 upon 2. So now you just have to take the LCM of this 2. You'll be left with 3. Hmm? Got it, right? Thanks. So this you can plot it at home. I'll share this slide, but okay. So there are some more questions. Okay, how will you calculate the energy? So this you can just consider E1. This is E2. Calculate the energy. So for this signal though, it's very simple, right? 2 square times 1. What will be the energy here? For this signal also I told you, right? 1 upon 2 is something, right? So here it will be how much? 2 times 1 upon 2 times A. What is the value of A here? 1 upon 2. So it will be 2, right? So 4 plus 2, 6 joule, right? Hmm. Nice. Okay. Yeah, and then this is also a triangular signal, so you can just solve it. This is not difficult. Yeah, this is the last question of our session. This type of questions for sure will be there, and I'm not bluffing also. So you will get this type of problem for sure in the exam. So you should be knowing how to solve this type of problem. It's not just one. You'll be getting 2 3 questions on the delta function itself. Okay, so the delta function you should be good at. Hmm. So the first session that I took, I remember I have discussed all the delta functions properties, and just you can just go through that slide itself. That is sufficient for you to understand the delta function. Here, how will you solve this problem?
Before this question, can you take properties of a direct delta function?
Properties of a direct delta function. Okay, just where is the okay. So I hope in yeah this is the first session that I took and I have discussed all the properties of this. Yeah. So what I said was in the impulse signal. So you already know that this is how generally you represent, and this one that the one that has been represented with the delta function is not the magnitude at that t equals to 0, but it is the area of a delta function that generally you represent 1. Okay, but if you just somebody asked what is the magnitude is infinite. Okay, that's why when we were differentiating right from 0 to 1, there was a sharp increase, right? So that's why we have represented in the form of an impulse signal. Okay, so the magnitude at t equals to 0 is infinite and the width is 0. Okay, and there is a proof also. So let's say example you have a rectangular signal, right? You have some width. If you start decreasing that signal, this will get start increasing because the area should come out to be 1. Okay, it will just start compressing it at one time. It will will start tending to 0, and this magnitude will start tending to an infinite. So that is how you'll get the area as a 1. So that's why for a delta function the area is 1, but the width is 0. Okay, I hope you are able to understand this. So the area is 1, and that is what we represent the delta function. So that's why if you'll just integrate the delta function from minus infinite to infinity, you integrate, or t minus to t0 also. So it can be represented as t minus to t. So like t of 0 minus to t of 0 plus also, and if you are just differentiating this function, you will get it as a 1, right? That 0 should be included. Okay, so you can write it from minus infinite to infinite, anything you can write. If let's for example you are writing from 1 to 2, then the delta function should be 0, because 1 to 2 the function is not defined, right? So the function where it is defined, then that is included in the time period, then the area will be 1, and that is how it is represented. The area should be this. The delta function generally is represented with the area. So yeah, this is how the function is mathematically represented. Okay, so this is fine. And for a discrete, this is totally different. We will be learning this in DSP the coming term. Okay, now there are the properties, and these are the properties for the delta function. Some property you already know, that magnitude, area, and all those things. Now the important properties. So let's for example a function ft has been multiplied with the delta function. What will happen? So you already know that ft can be any function, but if you're multiplying with a delta function is just defined at 0. So if you multiply these two function, all the other values get multiplied to 0, right? It will be left with 0, but only the f of 0 will get multiplied with the delta function, and that is what you will get the final result. Correct? So this was the fifth properties. Now the sixth property, the same property, you are just shifting the delta function. So now if you are shifting the delta function to t naught, so now the delta function is represented at t naught, t equals to t naught, right? So now if you are multiplying a function ft, right? So the ft at t naught only will be left. This will get multiplied with the delta function. That's it. Nothing, right? So ft naught got multiplied with del of t minus t naught, because other part of the ft, the function ft will be 0, because 0 is will get multiplied, because delta is just defined at t naught, right? Now the next property is, now you already know that the ft times del t will be f naught times delta t, because delta t is just defined as 0. Now if we are integrating that, so now if you will integrate this from minus infinite to infinite, you already know that f naught will be some constant. So you'll be left with f naught, and then you will integrate minus infinite to infinite of delta function. So this will be 1. You already know that. So you'll be left with f of naught. So this is what the functions will be, right? And the same, the next property also is the same. Only the the value is t minus t naught. So here also, if the minus infinite to infinite you integrate, or you integrate it for t of t naught minus to t naught plus, this should be included. T naught should be included in the integration, then only you'll be getting the value for this integration 1, and then this though you'll be getting as a constant itself, f of t naught. So these are the four properties. These two are the most important. You'll be using again and again every time. In the quiz also, whatever question has been given, you will just be using these two properties to solve that. Okay, so yeah, this should be and one more properties. Whenever you are scaling a delta function, you'll get a this, you'll just divide with the mod of that value. So whatever has been scaled, you'll just divide it with the mod of that value. Okay, and this is nothing but the same scale, like the shifted version of the ninth one. Okay, this is also important. So three properties you must be remembering. Okay, first, second, and this is the third. If you are able to know that, you'll be able to solve all the problems. Okay, is it fine? All the delta function has been
Yes, sir.
discussed. Now you solve this question. Yeah, so you just have to solve this. Now you know that this is a ft,
Yes, sir.
this
E
is a
power
delta function.
minus 2t, the upper limit is 6 and lower limit is minus 5.
Yeah, so the function is defined at the, you just need one, right? One is included here, right? So the all the properties will be applicable, correct? So if this was something like that, if it was 5 to 6, what would have been the value? 0. Okay, are you able? Yeah. So as here it is minus 5, so you'll have to use the properties of the delta function, and you already know that any function, so this is ft, is getting multiplied with delta function. So I already told you delta is defined at 1. So it will just be something like f of 1 times del of t minus 1, right? And integration of minus 5 to 6, correct? and then this will get integrated, this will be 1, so you'll just be left with f of 1. So you just have to put the value of f of minus 2 times 1, so e to power minus 2. Fine. Any doubt anybody has in this? No? Okay, if you don't have any doubt, I'll just give you one more question. So, and that is important also. Otherwise, I would not have told you. So, you should be knowing how to represent this type of a signal. Okay, mathematically. Let's say example, this is like 3, 4, and this is 2. Okay, so you should be knowing how to represent this type of a signal. You can just try it out. In one of the session, I discussed this also. So you can just, let's say example, there is a signal. This will go like this, and then it's going like this. This 1, this 2, and then this is the slope with a slope of 1. So you can just write it. This is unit step, again unit step, and then this is a ramp. So unit plus ramp signal. Okay. So here also you can just write it. This is a ramp signal. Okay. So or what you can write it. Write the equation of this and multiply with rectangular pulse from 3 to 4. Okay. That also you can write it. So the my only thing is this how to represent any signal in the form of like a decomposition of unit step or a ramp, that also you should be knowing. Okay, the way of representing any signal. Okay, that is also important. Any doubt anybody has in anything, you can just let me know. I'll just discuss that. Okay, so and any doubt that you have, you can just message in the G space. You can like tag me anywhere. I'll try to answer that in 24 hours. Maybe if the exam is will be close, I'll keep on checking. Okay, every hour or something. Okay, and if you're not getting the reply, you can just personally message me also via the Gmail itself. Okay, on the Discord also you can post. There are TAs also, so you can add tag him also. So that I hope you're already aware of the instructor. Those are taking sessions. Ankita is taking second, Akanksha, and then Avanya. So you can tag all those three also if I'm not replying. Okay. Any doubt anybody has? So I hope I have discussed each and everything that can be asked in the paper, and I hope you will be able to solve each and every questions. Okay, the paper that I saw was very simple, uh, similar to the mock that you have got. Okay, mock you try to solve it, not exactly the pattern, but yeah, the questions difficulty level you can guess from the mock. But the pattern I already told you, you'll be getting some 16, 70 problems. Okay, some of them will be MSQ, some MCQ, and then some will be NAT. Okay, the mark that have been given, maybe there can be more number of the true and false, but there are very less true and false that has been asked in your quiz one. Okay, not even a single, I guess. In quiz two, there are true and false, but not in quiz one. So yeah, you try to solve it as many as at least all the graded and practice. If you are able to solve whatever the number of questions will be, like let's for example, each has some 10 to 12. So if you just take 12 as an average, so 12 into 4, so 48 into 2, right? 88. Okay. So is it 88? No, 96. 90. Okay. So you just solve those questions, you'll be able to cross it. Okay. So yeah. So you have some 12 question each in practice and graded, and you have 8, 4 graded, 4 practice. So altogether 96 questions. Whatever question that we have discussed also is inspired from your graded practice and quizzes itself. So you'll be able to save it. Thanks everyone.
Sir,
Okay, any doubt? Any? Yeah, Chandan.
uh, sir, in quizzes, we have applied for the multiple subject. Then we get the each hour time for every subject or combined.
You will get a combined. You have written, right? You would have written earlier also, right? Quizzes.
Yes, that was the CBT. That's why I'm confirming.
No, you'll be getting the combined. So if you are able to write the some exam in 45 minutes, you'll be having 1.15 hour left for the other exam.
Okay, sir.
Yeah. Okay, so thanks everybody and all the best for your exam. We'll meet after the exam. We'll discuss the quiz paper in the next very next day. Okay, after your exam. All the very best and thanks.
Thank you, sir.
Thank you, sir.
Thanks.